Hello, welcome to another feed scroll generator tutorial for Autodesk Inventor. This time in tutorial number 9, we're looking at how you can group the bottles as they move along the shaft. So in this example shaft that we've completed already, you can see on the left the bottles are entering closely packed together, and by the end of the shaft on the right they are grouped together neatly in pairs. And this is the shaft that we're going to create as part of this tutorial. So what do we need to know in order to design this shaft? Well, we obviously need to know the pitch of the bottles at the start. We need to know the gap that we want between the groups of bottles at the end of the shaft, and all the usual stuff like the diameter of the shaft and the length of it and so on and so forth. So we'll just get cracking now, and let's escape out of this simulation, and let's close the builder form here for this completed example, and let's start ourselves a new part file here to create a new shaft from scratch so there's no cheating. Now when we hit the generate button inside this empty part, it's going to load a shaft with the default settings, which is not what we want for our finished shaft, so we're pretty much going to have to change all of the settings here in order to create the grouped bottle shaft that we want. So let's work our way down, starting off with this operation section. We're going to ignore this initially, and we're going to come back to it when we cut the second of the two threads for this shaft. Shaft rotation, let's say I want that to be left-handed. Let's say I want the length of the shaft to be 700 millimeters. Diameter I can of course set to whatever I like. Let's just make that 85 and hit enter. Bottle pitch, now I want the bottles to be, as we saw, packed closely together at the start, and then I want a gap of 80 millimeters between the groups of bottles at the end of the shaft in this case. So how big is the bottle? Well, let's scroll down and let's go to where we can sketch the shape of the bottle, and we're just going to keep a simple 52 millimeter diameter bottle here. Now this is the simplest example of how you might do a grouped shaft. Of course we could add bottle rotation here. If it was not a circular bottle, we could add movement of the bottle in or out, so on and so forth, but we're going to just focus only on the bottle grouping initially. We might add that on at the end of the tutorial, which you can do just with a single button click to add those other elements into the shaft. But the start pitch of the bottles we're going to want to be 52, but wait a moment here, we have to remember that we're actually cutting two threads. For a grouped shaft you need to cut the first thread and then the second one afterwards, so we need to double this bottle pitch because the second thread is going to fill in the middle. Second thread is going to cut this path through the middle here. So I've doubled 52 to 104. We said we wanted a gap of 80 millimeters in this case between the groups of bottles at the end of the shaft. So I can do the maths. 104 plus 80 equals 184. I'm going to hit enter. And then, as per usual, we need to set how long we want the bottle pitch to be the same at the start, and how long we want the bottle pitch to be the same at the outlet at the end of the shaft. So I'm just going to set that to be 1 revolution at the start by putting the same number in, and 1 revolution at the end by putting the same number in. Okay, the bottle position section, as you've seen before in previous tutorials perhaps, is the bottle's movement in and out as it moves along. We're going to keep this simple. We're not going to make that change as it moves along. We're just going to have a decent amount of engagement of the bottle with the shaft, say that kind of engagement there. And as I said, no bottle rotation initially here. It's a circular bottle, no bottle oversize initially, just to focus on what we're actually covering here. And because this is a super simple shaft, we're just going to drag these sliders for the number of loft profiles and the number of loft rails that are used to create this shaft. We're going to drag that all the way down. It'll still be accurate enough for manufacturing, and it will speed up the generation of the shaft. So if you're following along with this tutorial, hang on 1 second before you hit the generate button. There's something critical that we have forgotten if we're doing a grouped shaft. You might have watched the previous tutorial to this one, in which we created a double threaded shaft. We used this operation tool and we actually rotated the first thread and then cut the second thread. Check that out if you need. But in this case, we're not going to rotate between the first and the second thread. We're actually going to offset. And because we're going to offset, move the shaft this way, in order to cut the second thread, we're going to actually shorten the shaft by the amount that we move it. So the amount we're going to move it is this distance here, which is going to be 52 millimeters in this case. So we actually need to add 52 millimeters onto the length of our shaft, because we're going to lose that when we cut the second thread. And you'll see this in a moment when we actually come to it. So we need to add that extra distance on. Okay, and with that covered, we are now ready to hit generate and start creating the shaft. The app's off and running now. It's as per usual. We can cancel the generation if we realize we've made a mistake at any point. We can cancel it here. That'll take us straight back to this form, and we can input some different values and hit go again, or we can just let it run to completion. I'm going to fast forward the video here as per usual. Okay, so the shaft's created in just about 2 minutes, and I'm going to say yes, I do want to continue with another operation, because of course we want to cut the second thread here. We just cut the first one initially. So now, because we have an existing thread on this shaft, which is hidden in the moment for this preview, but we now have the option to toggle between cutting a first thread or a second thread here. And you see, if we leave it on the default, which is always to cut the first thread, if we were to hit generate now, what we will get is a warning that the existing finished solid body is going to be deleted if we continue. The first thread that we've just cut will be deleted. So we don't want to do that in this case. That's your warning. We want to cut the second thread and leave the first thread where it is. And when we do that, you see, when we turn this option on, we get a preview of what the current first thread looks like. So if we were to hit generate here now without making any other changes, it will cut the second thread exactly on top of the first thread. Now this is interesting, because what we could do is we could change the shape of the bottle. We could make this an elliptical bottle shape, and then we'd actually get the second thread of an elliptical bottle being cut on top of the first thread of a circular bottle, and we'd get a kind of compound bottle shape being created. But in this case, we don't want to do that. We don't want to do what we did in the last tutorial, which was rotate the first thread by, in the last one we did rotating that by 180 degrees, which looks like it's the right thing for grouping initially, because we're cutting a new thread in between the old threads, or the first threads. But look what happens when we get here. It's going to stay in the center the whole time, whereas we really want the two bottles to stick together and be grouped. Now you could actually do this two ways. I could change the end lead out and maybe a couple of the other values here, and keep having a play until I manage to get the bottle positions to be sort of stuck together there. But there's a much easier way, and that is to use a toggle here. And you see here, if I click just here, I can toggle between rotating the previous thread by degrees or offsetting the previous thread by millimeters. And this is much easier, because it just allows us to basically just shift the previous thread a certain number of millimeters in the Y direction, which means the two bottles will kind of stick together anyway, because they're both offset by the same amount. So if I enter 52 millimeters here and hit enter, then you see we get a subtly different result here. Looks the same at the start because the groups are together, but as the groups separate, you see that this new thread is going to be cut right next to the old thread here. It's going to stick, they're going to stick together and group them. Okay, and this is the reason why we needed to increase our length. We only really want 700 millimeters of usable length on this shaft, but we've had to add the extra 52 because look what's going to happen here. this whole area here, when we do a Boolean operation between the new thread, the new shaft, and this old shaft here, which you can see in red preview, we're going to lose this section at the front here. So that's why we needed to add the extra amount on. And actually thinking about it, if I was being sensible, I should have put a longer lead in for the bottle pitch of 104 millimeters, because we've lost 52 millimeters off of that. So I ought to really have made this 156 millimeters in order to get a true lead in of one revolution of a pitch of 52 millimeters in this case. So lessons learned there. Hopefully that makes sense. So as long as I make sure I'm cutting the second thread, I can leave all the other options the same. I can change them. We can have different bottle rotation. So we could, for instance, have the first bottle in the group rotating clockwise, the second bottle in the group rotating anti-clockwise, and grouping at the same time. We maybe we'll do that in a minute, but I'm just going to leave all the other options exactly the same and hit generate, and it's going to go and cut the second thread alongside the first thread for me now. So I will speed up the video as usual. Okay, that second thread is completed in just over 2 minutes again. Let's say that we do want to continue with another operation, because what I actually want to do is to run a simulation of both sets of bottles moving along the shaft. So let's just hit save on this file. Let's just call it anything we like and hit the simulate button down here. And then of course we probably also want to measure the length, the final length of this shaft to demonstrate that it is 700 millimeters, as I said. So I'm just using a space ball here to spin the shaft around. I'm just going to right click and hit measure, and you can see the total length is 700 there as expected. And let's run the simulation so that we can see. If you've seen any of the previous videos, if I hit the play button, it actually takes the app. It's running slowly initially because it's generating all of the frames for the video. So it's got to generate, well, in this case it's got to generate 71 frames. So it runs a little bit slowly first, but then it will speed up once it's done the first 71 frames. Okay, so that you can see the bottles being grouped here. I'm going to hit delete actually and change the speed of the simulation. Let's make it a bit faster, 4 times. So I'm just right clicking here to set the speed, and let's hit play on that again. So you can see the bottles being split up as they moved along the shaft there. Okay, so let's finish this simulation. If we wanted to extend the concept here by not having a circular bottle and by perhaps rotating one group of bottles one way and the other group of bottles the other way, what we would have to do is, the first time around we create the first thread, obviously apply one direction of rotation, and then the second thread that we cut, when we cut second thread on here, we just need to change the bottle rotation to be pointing in the other direction, and cut the second thread, and you'll get that result. Do you want to see it rather than me describing it? Yeah, okay, let's just do it quickly. I'll do it faster than before so that we you don't have to spend too much time watching. Let's just do an ellipse for simplicity. Of course we can import any bottle shape that we like. Let's maybe make that 30 and this distance 20 perhaps. Finish that. So we're going to need an initial pitch here of, let's say it's going to be 60, isn't it? So twice 60, 120, and we'll just make this maybe 200 at the end. We'll do the thing we said before of allowing the extra on the lead in of 60 millimeters, which is going to be our offset. So if I make that 180, we'll make our end lead out 200 to give us 1 revolution at the end. Okay, and we're going to cut the first thread this time because we have a new bottle shape, of course. We're going to include some bottle rotation. So anti-clockwise bottle rotation. Let's even maybe include a bit of bottle oversize. Why not, eh? Live a little. And so we'll start out the bottle oversize of 5 mil at the start, or maybe let's make that bigger so that it's obvious, and 0 millimeters at the end, or maybe let's make that 1 millimeter oversize at the end. So you should be able to see, if I make this, you can see this in the other tutorials, but if I make this, say, I don't know, 400 millimeters, the lead in, you can see that after about 300 millimeters, the oversize starts reducing until it goes down to 1 millimeter, a distance of 400 millimeters from the end. So there's our rotation and there's our oversize been added, and a different bottle shape, obviously. So we're just going to hit generate, and as we said before, it's going to warn us, hang on, you're going to delete the existing finished solid body, are you sure? So I'm going to say yep, that's fine. We'll fast forward this now. Okay, so first shaft's created in 2 minutes 18 seconds. We'll say yes, we do want another operation, and here's where we'll do the same thing, except this time we will reverse the direction of the rotation of the bottles. So let's cut the second thread as before. We'll group it. This time we're going to group it by offset it by 60 millimeters axially here. Let's see here, this is interesting, is that if we just rely on the offset of 60 millimeters, then we still have an offset of 60 millimeters when we get to the end here, but we actually want these two bottles to be side by side, so we need to close this gap at the end. So the way that we can do that is just to tinker around with the bottle pitch values, and I think if we increase this lead out value for the end pitch, let's try making that 240. If you watch carefully here, see that at the end the bottles are going to get closer together. Let's try making that 260. Hit enter if you just watch closely here. Yep, so that's looking a bit better. Let's maybe try 280. That might be too far, it's difficult to tell. There's going to be some good number crunching we can do for this, but I'm going to run the build and then check it in a simulation. And also, actually, what I see here is that I should, you see here the bottle hasn't fully completed its rotation here. It only has by, it looks like it has here, close to the end of the shaft. I should really have increased these values to start the bottle rotation maybe a bit later and finish the bottle rotation maybe a bit earlier. I should have increased these values, but we'll leave those for the moment. So let's try a value of 280 here. We might get a slight overlap between these two bottles at the end, in which case all we have to do is just run another quick build and fix it. Of course, we did say we were going to switch the bottle rotation to be in the opposite direction, so let's do that here now. We've now got clockwise bottle rotation. We could change the amount on the lead in and lead out, but we'll leave those the same. Leave the bottle oversize the same, and we can just hit generate here again. Right, there we go. We've got both threads cut here, and I'll say yes, I do want to continue with another operation because I want to run the simulation of the shaft. So let's just save this and hit simulate. I remember what I should have done here, because we had an offset of 60 millimeters. I should have made this 760 instead of 752. My mistake. We'll see the actual length of the shaft is under 700 millimeters now. It's going to be 692, isn't it, I guess. But let's take a look at that alternate rotation of the bottles anyway, so that we can see. Okay, the first thing we see is that I needed to change my lead in, my lead out value, because we've got a clash here between the bottles. You can see the 1mm off bottle oversize that I put in there, which is very nice. It's got a nice smooth 1mm offset. And we've got a 8mm offset of the bottle at the start. It's a bit excessive, isn't it? But just wanted to demonstrate the principle. And if I drag this along, you can see the bottles rotating in opposite directions as the bottles move along the shaft. So it looks like we could actually see, let's actually check the bottle data at the end here. This will help us to establish what I need to change that value to. So if I look at the bottle data, the true pitch at the end is 38.34 between these end bottles. So we wanted it to be 40 if they're touching. So we'd have to tweak that value a little bit. So let's just collapse that. So what we'd have to do in this case is we would have to go back and let's escape out of this. We'd have to go back and increase this value to change that. Oh, sorry, decrease this value, isn't it, in this case? But you get the idea, and hopefully this tutorial has been a good introduction into what you can achieve by using the different methods of cutting a second thread, either rotating, as we saw in the previous tutorial, or offsetting the previous thread, and how you can build a single compound shaft with multiple steps. Thanks very much for watching.